Okay, for this problem, we're going to try to solve the triangle, but this is a little bit different, kind of unique situation. So notice we have an angle A here, and the side A, and then we have side B. So we're going to start with law of sine, and find the angle B. Now, what's important to consider is the fact that the unknown side, this B, is bigger than the other side given to us. So this creates a little bit of a dilemma. So let me go through the start of this. So we'd have sine of 41.9 degrees over 186.2 equals sine of B over 241.4. And so I'll clear this out, 241.4, 241.4, I'm going to multiply. And let me get my calculator out here. So let's see, 241.4 times sine of 41.9 divided by 186.2, and make sure it is in degree mode. So there we go. And I get 0.86582 if I round to 5 places as the instructions give us. So 0.86582. Okay, so that's pretty normal there. But what we have to consider when we find angle B, this is what we call the ambiguous case. So if I said sine, let's change that to, I go to blue, by the way. If I go ahead and say B equals sine inverse of 0.86582, and I'm going to be honest, I'm just going to take the value of my calculator and input that, which goes to more decimal places, but there to there, boom. I get 59.97859. So 59.97. Well, let's go to 2 places the way they do in the book or on the homework assignment. So 59.98. Okay, but this presents an issue because sine inverse only returns values in the first and fourth quadrants. So if this happened to be something that's over here in the second quadrant, we wouldn't know. So what it did return was this 59.98. And again, this happens when the unknown side is bigger than the other side when you're doing law of sine. So you have like an angle, a side-side angle situation. So it could be that 59.98 degrees is a reference angle. So we would take 180 degrees minus 59.98 degrees, and we would get 120.02 degrees. So that's the second potential triangle here. So there's 2 potential triangles in this case. I guess I didn't need the degree symbol because it's there, but whatever. Okay, now, given that, we're going to finish solving this. So we want to find the case that with the B1, what would our C1 be? So C1 would be 180 degrees minus 59.98 degrees minus the original A is 41.9 degrees. And I get 78.12 degrees. And while I'm at it, I'll find my C2. That's the other potential value for C, given the other triangle. So again, 180 degrees. And I just realized on this one I should have written 120.02. Okay, 180 degrees minus the 120.02 degrees minus that A, 41.9 degrees. What do we get for that? I get 18.08. Yeah, it's getting sloppy down there. It's hard to write at the bottom of the screen. Not that I've mastered writing on the screen in general. 18.08. I should have written 78.12 degrees here. Okay, so now we have the angles for C. We want to find side C in these two different situations. So I go back to my original so I don't propagate round-off error. So I'll do my sine of 41.9 degrees divided by 186.2 equals sine of the C in this case is 78.12 degrees over C1. So I'll cross multiply. Sine of 41.9 degrees times C1 equals 186.2 degrees times sine of 78.12 degrees. Divide by sine of 41.9 degrees. And C1 would be I get 272.84. 272.84. Now we'll do the last one. Kind of getting low on space though. Let's try, I guess we'll start here. Sine of that same 41.9, that's the A, over the side A, 186.2 equals, let me just draw a little line so to keep it separate, over sine of 18.08 degrees. So notice this case, the C is much smaller. In the first case, the C was bigger than A, so the answer was bigger than, the side C was bigger than A. Now we have an angle smaller than A, so the side should be smaller. That's kind of our little informal checking there. So I'd have, make sure I stay within the screen boundary, C2 equal C2 times sine 41.9 equals, yeah, I'm getting close, equals 186.2 times sine of 18.08. So my C2 would be 186.2 times sine of 18.08 degrees, that's an 8 there, all divided by sine 41.9. So it's really the same calculation degrees as the one above, but just that sine angle changes. So let's go ahead and do this. The nice thing about a TI-89 is I can just go back up to that last value and type over 118.08. I have 86.5. So here's an error issue. The book says, or the computer says 86.51. I came up with 86.52. So I'm not sure what you would get if I get mark it wrong if you're off by that. So their answer, if you're going to be, if this is the same numbers for you, 86.51 is what the book says or the computer says. Okay, I hope that helps. Let me know if you have any more questions about this.